Tonight, you're going to do something no other animal on Earth does. You're going to take raw ingredients, apply heat, and eat the result. You'll call it dinner. Your ancestors called it the most important discovery in the history of the species, and they didn't even know they'd made it. Here is what cooking actually did to you. Not to your culture, not to your recipes, to your body, to your skull, your jaw, your gut, your brain. The story starts with fire. But it doesn't end where you think it does. The oldest confirmed evidence of controlled fire used for cooking comes from Wonderwork Cave in South Africa. Archaeologist Francesco Berna at Simon Fraser University led a 2012 study published in the Proceedings of the National Academy of Sciences. He found burned bone and plant ash in sediment layers, dated to approximately 1 million years ago. 1 million years. That is 800,000 years before agriculture, 997,000 years before the first restaurant. And the species doing the cooking wasn't even Homo sapiens. It was Homo erectus, a different human, an earlier one, which means cooking predates your species by roughly 800,000 years. You didn't invent cooking. Cooking invented you. That is the central argument of biological anthropologist Richard Wrangham at Harvard University. In his 2009 book, Catching Fire: How Cooking Made Us Human, Wrangham laid out what he called the cooking hypothesis. The idea that the control of fire and the cooking of food was the primary driver of the anatomical changes that separate modern humans from every other primate. Not tools, not language, not social complexity. Fire. Specifically, what fire does to food before it enters your body. Here's the mechanics. When you cook food, you break down cell walls, you denature proteins, you gelatinize starches. In plain terms, you pre-digest it. The work your gut would have to do to extract energy. From raw food, your body does less of it because the fire already did it. Wrangham and his colleagues calculated that cooking increases the energy yield from meat by roughly 30%, and from starchy plants by as much as 78%. Same food, same calories on paper, but your body pulls nearly double the usable energy. From the cooked version, that surplus changed everything, because energy is expensive. And digestion is the most energy-expensive process. Your body runs a large gut, the kind you need to extract nutrition from raw, fibrous food, costs calories to maintain. When cooking started delivering pre-processed food, the gut could shrink. And it did. Compare the gut length of humans to other great apes, chimpanzees, gorillas, orangutans, and ours is dramatically shorter relative to body size. Primatologist Catherine Milton at UC Berkeley documented this in comparative anatomy studies. Human gut architecture is closer to a carnivore's than to our closest relatives. We have the digestive system of an animal that eats pre-processed food. Because we do, we've been doing it for 1 million years. But here is where it gets stranger. The calories freed up by shrinking the gut didn't disappear. They went somewhere. They went to the brain. The human brain is the most metabolically expensive organ in any animal relative to body size. It consumes roughly 20% of your total energy, while making up only 2% of your body weight. Running a brain this size on raw food may simply not have been possible. Wrangham's argument, supported by the fossil record, is that the brain expansion seen in Homo erectus and later Homo sapiens tracks almost exactly, with the evidence for controlled fire use. Bigger brain, smaller gut. Same timeline. The cooking fire wasn't just warming food, it was funding the organ that eventually built cities, wrote symphonies, and mapped the genome. Now here is the part almost nobody talks about, because the standard story stops at cooking equals smart humans. But Wrangham's research goes somewhere darker. Cooking didn't just change what we ate, it changed when we were vulnerable. Raw food takes time to process. Chimpanzees spend roughly 6 hours a day chewing. 6 hours. That's not eating. That's a job. When cooking compressed that time, soft, cooked food requires a fraction of the chewing. Something opened up. leisure, conversation, planning. But also, a campfire is visible in the dark. A campfire announces your location. It draws every predator and every rival group within miles toward a single point of light. The groups that gathered around fire were also the groups that could be found and attacked. Anthropologist Polly Wiesner at the University of Utah spent decades studying the Kung San of the Kalahari, one of the last hunter-gatherer societies that still maintains traditional fire practices. Her 2014 paper in the Proceedings of the National Academy of Sciences documented what happens around those fires. Daytime conversation among the Kung is mostly practical. Complaints, tasks, arguments about resources. At night around the fire, stories, myths, history, ritual, identity. The fire wasn't just cooking food. It was cooking the group. It was the original theater, the original classroom, the original church. Every institution humans have ever built, the gathering, the story, the shared myth, started around a fire after dinner. Think about what your body still carries from that. You are drawn to fire, not as a metaphor, literally. Psychologist Christopher Lynn at the University of Alabama published a 2014 study in Evolutionary Psychology showing that watching firelight, even a recording of fire, measurably reduces blood pressure and increases feelings of social connection. Your nervous system relaxes around fire, the way it relaxes in no other light source. You have been sitting around fires for 1,000,000 years. Your body remembers even when you don't. And the jaw. The human jaw is significantly weaker than any other great ape. We have smaller molars, weaker bite force, smaller temporalis muscles, the ones that run. From your jaw up the side of your skull. In chimpanzees and gorillas, those muscles are so large, they attach to a bony ridge at the top of the skull, a sagittal crest, just to anchor the force. We don't have that ridge. Because we don't need that force. Our food is already soft before it reaches our teeth. Has been for 1,000,000 years. The shape of your skull, the high rounded dome, the flat face, the delicate jaw, is the shape of an animal that cooks. You can read the history of fire in your own face. Nobody is suggesting you go back to 6 hours of chewing, or that the pre-cooked world was better. It wasn't. Life expectancy without cooking, without the caloric surplus, that built brains and kept infants alive longer, was brutal and short. Cooking didn't just make us smarter, it made childhood possible as we know it. Human infants are born helpless and stay helpless for years because the brain is still growing. That extended dependence requires food soft enough. For a child without molars to eat, cooked food. The fire didn't just change adults. It changed how long you got to be a child. So the next time you heat something up, microwave, stovetop, gas flame, you are participating in a 1,000,000-year-old technology. The oldest technology humans have. Older than the wheel, older than writing, older than your species, and every time you sit down to eat with other people, you are reenacting something that built the social architecture of the human mind. The meal was never just fuel, it was the meeting, the story, the thing that made a group of frightened, hungry primates feel briefly like they belonged somewhere. The fire is smaller now. The need isn't.